what is the meaning of a sampling design, we will study the different types of sampling designs. So, this is a very concise table. So, in sampling you have probability sampling and non-probability sampling. So, the main difference is in probability sampling, every unit has an equal probability of being selected for the study. In non-probability sampling, every unit does not have an equal probability of being selected for study. So, in probability sampling, we will be seeing a few types: simple random sampling, which is unrestricted, and we have some restricted sampling, complex random sampling like cluster, systematic, stratified, etc. Then in non-probability, we have haphazard or convenience sampling, and you have purposive sampling, quota sampling, judgment sampling, so on. So, we will be seeing what each of these mean in the coming video and possibly in the next video. First, let us take up non-probability sampling, because it is easy to understand. So, there is no bias for estimating the probability that each item in the population has of being included in the sample. So, in non-probability sampling, the researcher purposively chooses the units of the universe for constituting a sample on the basis that the small mass that they so select out of a huge one will be typical or representative of the whole. What does this mean? Let us say I want to, we will take the same example, I want to take students of 6th class for study, right. So, I choose some schools out of my knowledge, I choose some schools, because I know that these schools which I choose for study, they represent all the schools in my city, they represent all the schools in my city, right. So, that is the meaning of this statement. The researcher, I choose purposely because I know the school, or I have the names, or for some reason I choose it, and I feel that these schools are representative of the schools in the entire city. So, now tell me, will my bias come into it or not? Definitely. I may be a convent output, I might have studied in a convent when I was a kid. So, I will, by bias inherently I will choose all the convent schools, or I may have studied in a government school. So, I will choose all government schools for study, because that is what I know, right. So, in this kind of sampling, non-probability sampling, the judgment of the researcher or the bias, the prejudice will there is a chance of it coming in. I do not say it will definitely come, but there is a fair chance. Okay, though I have studied in a convent, I am matured now, I am grown up, and I know that there are other schools. So, I will select some convent schools, some government schools, and some other schools, private schools for my study. So, there is a possibility of the bias of the researcher entering the sampling. So, in this non-probability sampling, let us say, see what are the different types we can define. The first is called as the convenience sampling. The name itself tells what it is. It is convenient for me. Okay, it is also called as accidental haphazard. I have to choose schools. Okay, let us say I live in Jayanagar in Bangalore. I will choose most of the schools I will choose in Jayanagar and JP Nagar, because they are all close to me. I do not want to go to Yelahanka, which is far away in this traffic, or I do not want to go to Electronic City, right. I have to choose some working women for my study. I live in Electronic City, so I just go to the few IT companies there, and I survey the working women there. That is the meaning of convenience. just because it is convenient to me. The convenience could be anything, ease of access or money, something is convenient. Now, this is not, obviously you can see this has no meaning, I am just choosing because it is convenient to me. It is also called as haphazard, accidental, and very difficult for you to establish a cause and effect relationship, because what you are choosing, the sample you are choosing out of convenience may not be reflective of the entire population. So, obviously you can see it is not a very good way, but may work in some cases. For example, supposing I want to let us say I am doing some study on auto drivers, then fine, I can just go to 2-3 auto stands near my house and take, and more or less they will represent the general attitude of auto drivers all over the city. So, in such a case convenience sampling may work. Clear? It may work in some, but it is generally not a very good way of sampling. Next, I have a purposive sampling or judgmental sampling. Here what happens is I purposely choose something. The researcher selects a sample based on experience or knowledge of the group to be sampled. This is also called judgment sampling. This has potential for inaccuracy in the researcher's criteria and resulting sample selections. As I told you, because I am convent bred, I know how convent children study, so I will choose convent schools for my study. That is judgmental. Okay. That is where I am going to choose a sample because of my knowledge of that. Are you clear? And I feel, okay, if I want to select a group of women for study, I feel that women who wear saris are very old fashioned and not very not up to date with the latest trend. So, I will choose only women who wear jeans to their workplace, because I feel they are more forward in their thinking. No, I wear saris most of the time, but I can easily say that I am not a backward orthodox kind of a person. Are you clear? So, judgmental sampling is again not good, because it is based purely on the researcher's judgment. Then the third is quota sampling. This is okay. In quota sampling, what I do? A researcher gathers data from individuals possessing identified characteristics and quotas. So, what I do? If I want to study a group of women, I just want to see the exercising habits of women, let us say, in the age group of 20 to 30. I want to do some study on the exercising habits of women in the age group of 20 to 30. Excuse me, I keep telling women because I am a woman. So, what I do? I decide I want 100 people. I want to study 100 women, let us say. So, now I give a quota. I will say I will choose 10 women who are still studying. So, they will obviously be in their early 20s, and I will choose 10 women who are working and who have children. I will choose 10 women who are working and do not have children, right, and I will choose 10 women who are not working and who do not have children, so on and so forth. So, I think I get a fairly good idea, because I am giving a quota, that is called as a quota, right. So, I take 10, I give a quota of 10 for women who are studying, I give a quota of 10 for women who are working and with children, and so on and so forth. That is quota sampling. So, the researcher will select the sample based on a particular characteristic the sample possesses, which we call as the quota. Next is very interesting, snowball sampling. I don't know many, now let us say I want male entrepreneurs. I want to do some study on male entrepreneurs. I don't know anybody. I just know two people. So one is my friend's husband who is an entrepreneur, and another is my brother-in-law who is an entrepreneur. I know two people, right? So I select them because I want to study male entrepreneurs. So I select two males I know who are entrepreneurs. Beyond that I don't know. And then what I do? I ask them, okay, I ask my friend's husband, do you know any other entrepreneur? You tell me. So I want a survey. I am giving some set of questions to the entrepreneurs. Were you working earlier? Right? Did you have the seed money? Did family fund you? Did you get an angel investor? Something like this. Some questions I am giving. I want some entrepreneurs, at least 50 entrepreneurs to fill up my survey question. So, but I know only two. From where I get 50? So I will give it to these two people and I will say, hey, you share it with two more people and ask them to share it. Snowball, right? A massive movements can take place with this snowballing effect. I don't know if you people know about a yoga program called Habit. It's called habit building. So Saurabh Bhatra, he is a person, and I very keenly watch it, though of course I don't do that yoga, I do my own, but the way it has a snowballing effect, in maybe 7-8 years now he has around 80 lakh subscribers. So every day somebody tells me, hey, join Habit, join Habit, join Habit, then I know it, I forward it to 10 people, they forward it to, so that is the snowballing effect. The same thing we do in sampling. When the researcher does not have enough of contacts or enough of information about the samples. So the researcher selects a small number of participants. This is obviously possible only when it is a human participation needed in the study, not for products. Okay. Then the participants are asked to recommend other potential participants for a study. This is also called as chain sampling. Name itself tells it goes like a chain referral sampling or simply referral sampling. It is not representative of the population being studied because it is not chosen through random selection. Now, I will tell you what happens. I know the two people, no, entrepreneurs. Let us say their business has got a turnover of some 50 lakhs a year. The business turnover is 50 lakhs a year. Obviously, their contacts, etc., you can say that they will also be maybe if not 51 crore, not more than that. So they will not know somebody, they will not have direct contact to somebody like Mukesh Ambani or Adani or some big entrepreneur, or somebody who started Myntra or Nikhil Kamath or something like that. So it may not be representative of the entire population. I cannot make a conclusion of all male entrepreneurs by just this snowballing effect. I may not get a suitable sample. So very difficult to make statistical inferences with this kind of sampling, with this snowball sampling. You cannot make statistical inferences easily. Okay, you can't say 80% of the entrepreneurs who started did not have seed money, or you can't say 60% of the entrepreneurs got the seed money from family. I can't make such statements. Then self-selection sampling. The participants express desire to be a part of the research. So they come and tell, okay, I want to be a part of the research. This can happen in academic institutions, research organizations, where somebody knows some study is going on and they come and say, yeah. Or the government may be undertaking some research and they will just publicize, willing participants please come, they will come. Very common in medical research. Medical research, what happens? Let us say there is a trial. I am sure you would have seen such advertisements in when you open your mobile. They will say there is a new ear device which has come, hearing device. So people who are born before 1960, we can volunteer for a trial. So I go and volunteer. So somebody mainly first they advertise. The people who want, the researcher will advertise just to the public or a group of people, and whoever is willing come and be a part of the study. So maybe we have found a company has found a new drug for cancer. So they'll say, cancer patients, you can come forth and be a part of the study, trial studies. So that is called as self-selection sampling. So you see, these were all non-probability, because everywhere the researcher's bias or contact is important. The researcher comes into play. My way of thinking, my judgment, my contact, my knowledge, etc. comes into thinking. There is no, so every person does not have an equal probability, right, of being selected. That's the point in non-probability sampling. Now what is probability sampling? Very simple. See, supposing I have a couple of, let us say I have 10 colors of balls. I put it in a bag. I just close my eyes, randomly shake the bag and take out a ball. It could be any of the 10 colors. So every ball has an equal probability of being picked. Now I can say sampled. So probability theory is all about that. So you can apply statistical methods of analysis only under such cases, where every item has an equal probability of occurrence, So all the sampling designs which fall under this, they all come under probability sampling. Obviously you can see there is no scope for the researcher's bias. I may write, let us say I put the balls in the bag. I like red color, I like yellow color, let us say I like yellow color. So I can't say that the probability of me picking a yellow ball is higher, no. And let us say I don't like red, but I can pick up a red ball. The chance that I pick up an yellow ball or a red ball, both are same. The probability is the same, right? So probability sampling has no scope for bias, Doesn't mean there is no scope for error. Error is possible, but researcher's bias will not be there, right? So moving forward, in probability sampling, every item of the universe has an equal chance of inclusion in the sample. It is like a lottery. We all gamble, thinking that we will win the jackpot, right? It is to say a lottery method in which individual units are picked up from the whole group, not deliberately, not because I like something, not because I know something, or not because I feel that would be better. No, there is no knowing, feeling, everything, not deliberately, but by some mechanical process. So I must still have a process for selection. Here it is the blind chance alone that determines whether one item or the other is selected. Nothing but chance. Whether I pick up an yellow ball or a red ball is just a chance, that's all. Both have an equal chance. Therefore, the results obtained from probability or random sampling can be assured in terms of probability. That means what I told you, you can apply statistical tools for inferences. There are so many statistical tools. So you can apply all those when you have a probabilistic sampling. We can measure the errors of estimation. So once you talk of statistics, you can talk of error. You can talk of the probability of occurrence. And then so you will know, when I generalize a statement, you will know that, it's like saying, this current has 25 amperes, it can carry this device with an error of plus or minus 5%. So, I will know, I can determine statistically what is the error. So, the user or the person who makes use of that research finding will be prepared for it. They will know that there is going to be an error, and that error, if it is acceptable, they will accept the research finding. If it is not acceptable, they will not accept the research finding. So, the first one, simple random sampling. What I do? I have the entire population. So, I have all the balls, I put it in a bag, I just take one and pick it up, random. That is called as random sampling. So, in random sampling, there is no pattern of selection, there is no pattern of selection, and mathematically there are many ways in which random numbers can be generated. See, if I ask you to tell the numbers from 1 to 10, you have 1, 2, 3, 4, 5, 6, we go on. So, it is in a sequence, right. If I have 20 people and I say randomly tell a number between 1 and 100, somebody will say 72, somebody will say 17, somebody will say 1, somebody will say 100. And there is a particular way in which random numbers can be generated. There are algorithms to generate random numbers randomly. So, in simple random sampling, I just randomly pick up the objects. If I want 1000 people for study, I just randomly pick up 1000 people. I do not have any criteria. I do not say they have to be in this age group. Okay, if in an age group I want, in that age group if there are 10,000 people, I randomly pick up. I do not have any pattern for it. That is called as simple random processing, very easy to do, very not at all difficult. So, the method of sample selection which gives each possible sample combination an equal probability of being picked up and each item in the entire population to have an equal chance of being included in the sample. This applies to sampling without replacement. Best method to achieve a representative sample. Best, very good method, random. What is this replacement? We will see. Supposing I have a bag of balls, very easy for you to see. Let us say for my study I have to choose 2 balls, okay, 2 balls. So, let us say there are 10 colors, okay. Now, what I do? I pick up, so how many combinations I will have? So, I can have yellow red, then I can have yellow blue, yellow green, yellow pink, then I can have red, blue, so many combinations. Let us not go into the numbers, so many combinations are possible. So, now I pick up my first ball and my second ball. So, I find it is yellow and red, I put it back. Next time I pick up 2 balls, then I find it is pink and purple. So, you see it is a combination. So, every combination has an equal chance of occurring. That is the meaning. Without replacement means what? I will not get an yellow and yellow because there are 10 different color balls. Once I pick up an yellow, I am not putting it back. So, the next one cannot be an yellow. So, this is something to do with detailed statistics, we do not need to know. Just if you understand the meaning, it is enough. So, in simple random sampling, what is it? The samples are randomly picked from the population. The samples are randomly picked from the entire population, they are randomly picked. And every combination and every unit has an equal chance of occurrence. One of the best ways to get a representative sample, there is no bias because everything has an equal chance. The selection process. So, how do you select? First you identify and define the population, then determine the desired sample size. So, you take the frame first, the population. Out of that population, how much you want, what is your sample size, and you list all the members of the population. You can assign numbers to each of the members and you select arbitrarily random numbers. So, you see this image very nicely tells you there are 15 people, this is the population. I have not differentiated male, female, nothing. 15 people are there. Okay. I have given numbers to them 1, 2, 3, 4, 15. I have given numbers, 15 people, 15 numbers. I want 5 people, randomly some 5 numbers. I will just close my eyes and I will call a child and said give me 5 numbers between 1 and 15. So, the child will say 2, 5, 9, 13, 14 randomly. So, I pick up those people 2, 5, 9, 13, 14. I call, or maybe the child may say 1, 7, 11, 10, 15, I will pick up those numbers. Very easy, very easy. Or another way what I can do, I have the telephone directory. Okay, there are 48 names. I just open a page, maybe a telephone directory or the employees. I just randomly open a page, and then they are given some serial numbers are given there. So, I need 5 or some samples, 5 samples. I take some random number and just choose. Okay, I choose align these people, this 5 people I choose randomly. I want to see the employee satisfaction in the company. So, I go to the HR department and I say you give me the list of all the people in the company. I take it and I just use a random generator on the computer. There may be 10,000 employees. I need 500 people. So, I go to the computer, generate 500 random numbers, and then I call those people and I choose them for my study. No bias anywhere. Everything is by chance. Easy, na? And you see, it's better than all your non-probability sampling where the researcher's bias comes. So, the advantage of this is it is easy to conduct, fair and unbiased, requires minimum knowledge of population. I do not even have to know, do you have to know anything about these people? No, I do not have to know who they are also. No knowledge of the population is required, and you have a very high probability of getting a good representative sample. That means you can generalize, your generalization will be more authentic and valid, and it will meet assumptions of many statistical procedures. I told you, you can use lot of statistical analytical tools. The disadvantages, identification of all the members in the population can be difficult, and contacting all the members of the samples can be difficult. Okay, I do this and then these 3 people may be on sabbatical, not available. So, I may not be able to contact them, or they may be bad people, they do not want to respond to my questionnaire, and there are chances of errors, and it requires a large population size. The population size has to be really large. So, we will next proceed to more complex probability sampling methods. Thank you.